So yeah, so I guess this is a fireside chat, and the reason I talk about it that way is because this isn't all science. So don't you can put down your pens and notebooks and just kind of enjoy the story. And this talk is it's going to be part history and part science and kind of part social psychology. But I hope you find it interesting. It was really quite an adventure for us as we went through this, and we learned a lot of things, not only about science and not only about Alzheimer's disease, but also about Russian German history that none of us knew anything about before this all started. So I've titled this Catherine the Great meets Alois Alzheimer, the Volga German research study. Let's see, what do I hit to forward it? It's not forwarding. Oh, there we go. Okay, now I know what to hit. So here she is. This is the great Catherine the Great, one of the most famous rulers of Russia. In the Russian mind, she's probably right up there with Vladimir Putin.
So now we're going to want to change to 10x.
So Joshua, you may want to mute yourself. So there are a couple of things to know about Catherine the Great. Her story in itself is interesting, but we don't have time to go through her full story. But the situation was, and some of the pieces of this story become important later on. In the 1740s and 50s, the leader of Russia was Elizabeth, the Tsarina Empress Elizabeth. Her husband had died, and she had become the Empress of Russia. And she had a son named Peter, who would become the Tsar of Russia when she died. And so she wanted to match Peter with an appropriate wife, and she wanted it to be someone she could control. She was a very controlling empress. And she knew about this second cousin of Peter's, who was a princess in Prussia. Her name was Sophia Frederica, and she was 16 years old and was in Prussia. And although she was a Prussian princess, her family was actually not very wealthy, not very well-to-do, and were not primary in any way in any of the royal families. But there she was, and by pedigree, she was a second cousin of Peter. And Elizabeth, the Empress of Russia, knew about her and thought that she was distant and not very wealthy, but pretty. And so she would be someone she could control. So she arranged for her to become married to her son, Peter, much to the delight of Sophia's parents. And Sophia was 16. She didn't really know what was going on. And so she married Peter in 1745. And the Empress, Peter's mother, Empress Elizabeth, tried to control the two of them as best she could. And she was very good at controlling Peter. She wasn't so good at controlling Sophia. And then in 1762, Empress Elizabeth died, and Peter became Peter the Third, Peter, Tsar of Russia, and his wife, Sophia, became Catherine. Peter was very ineffectual, incompetent. No one particularly liked him. And so within a few years, there was a coup. And during, not only was Peter overthrown, but he was murdered. And as you can imagine, there was a bit of a tussle over who would become head of Russia. But they decided to choose his wife, Catherine. And so Sophia Frederick of Prussia became who is now known as Catherine the Great. And she wasn't an easily controlled, ineffectual person. She became the Great for a reason. And she had a 34-year reign, which is one of the longest reigns of any of the people who headed Russia. So now notice the date that she became empress, 1762. And what was going on in Europe at that time was something called the 7 Years' War, which ended after 7 years in 1763. So just after she became Empress of Russia. And the 7 Years' War was really a world war. It was it involved France and Spain and Prussia and Austria and the United Kingdom, the British Empire. And in North America, we know it as the French and Indian War. But in Europe, it was called the 7 Years' War. And it was a terrible war. It went on for 7 years, and it was a disaster. And it was particularly hard on the, as wars so often are, on the civilian population. And one of the places that was devastated and impoverished by this war was the Rhineland, Hesse, Palatinate region of what is now Germany. But of course, back then, there was no country of Germany. It was all independent, small states. But they had been fought over several years in a row, back and forth between Prussia and other armies and the French. And here is Hesse, which was one of those regions that was devastated and impoverished by the 7 Years' War. And I want you to particularly notice two cities in Hesse, Frankfurt on Main, here at the bottom, and Fulda over here on the Fulda River. They're actually quite close to each other. So this area was completely devastated and impoverished, and it became important in the history of Russia because Catherine the Great's advisors, she was quite young and new on the job, her advisors told her that the southern area that Russia theoretically controlled was not under good control, and that it was being attacked by Tatars and Cossacks and the Ottoman Empire, and they were very afraid they were going to lose the territories along their southern boundary. So they said, what we need to do, in addition to defending this area, is we need to populate it. We need to fill it up with farmers and citizens that we can control so that we can say it really is ours and we are in control of it. No one in Russia particularly wanted to move to this area. And Catherine had a great idea. She said, my compatriots back in the German states have been wiped out by the 7 Years' War, and we should be able to convince them to immigrate to this area, and we can settle it with Germans. And they said, oh, that's a terrific idea. And so they sent emissaries to these devastated regions in the German provinces, and they told them that if they would move to the southern territory of Russia, they would have a free and independent life. They would be free from military service, quote, for eternal time, that they would have land that was cheap and there was lots of it. They wouldn't be taxed. They could administer it themselves. They would have religious freedom, and they would have their own educational system. And that marketing worked. And so you can see over here, this area of the little states in what is now Germany. These lines are all the lines of the immigration to Russia that happened in the 1760s and 1770s. There are two that are especially pertinent to this story, and even today's world, by the way, some of these groups went down to this area, which is now the Crimea and the Ukraine, just north of the Black Sea. And they actually became known later as Black Sea Germans. And we'll hear about them a little later. Another group, and many of these were from Hesse and the Palatinate, took a longer trip through the Baltic Sea to St. Petersburg, and then over to the Volga, and came down the Volga River and settled in this region of the southern Volga River. And this was the entire area that Russia was trying to control. Isn't that interesting? Russia's still trying to control it today, 200 years later. So here's a focus on that Volga region. This is the Volga River flowing down through that region. And the German immigrants settled on the west side of the Volga and on the east side of the Volga. And they divided themselves by religion. The Catholic Germans settled on the east side, and the Lutheran Germans settled on the west side. And they formed communities, they formed cantons, and here's the one that's pertinent to our study, the canton of Frank, named after one of the families from Germany that settled there, the Frank family. So they settled. Thousands and thousands of Germans moved to this area. They developed farmlands. They were very good farmers. And they also had very large families. They typically had 10 to 15 children. And then time passed. Catherine died, and there were several czars that followed Catherine, including this one, Tsar Alexander II, in the late part of the 19th century. He was Catherine's great-grandson. And they said to the Germans in the Black Sea area and in the Volga area, well, we're having a war with the Japanese called the Russo-Japanese War, and we need soldiers. And so we're going to recruit you Germans to join the Russian army. And they said, no, Catherine told us that we would never be recruited. We would never be drafted. And they said, well, that was Catherine. This is now. And they started drafting the Germans into the Russian army. They also ran out of farmland. That was probably partly the German fault. They had so many children, so many sons, and they were giving their farmland to their sons, inheriting it, that they had so many sons, they were running out of farms to divide up. And later on, they became viewed as foreign aliens. This was quite a bit later, but for example, in World War I, Germany became the enemy, and they became very unpopular by the Russians. They also were told that they could no longer speak German. They needed to learn Russian. So that promise of their own education control disappeared. They were also told that they could no longer be Catholics and they could no longer be Lutherans. They had to be Russian Orthodox. So they lost their religious promise from Catherine. And so what happened was they said, this is no longer a good deal. We need to look for better farmland and more freedom to do the kinds of things that we want to do. And so they started looking around. And they probably used this famous German quote, "We grow too soon old und too late smart." So in the time after the Civil War, remember, the United States was now building the Trans-American railroads. And so all this western area in the United States had huge amounts of farmland, and the country, the government, the states, the territories, and the railroads wanted to populate it with farmers. And they actually advertised in Europe for immigrants to come over and settle this land and become farmers. And the Volga Germans and the Black Sea Germans got a hold of these advertisements. Just, it's a redo of what had happened to them 100 years before under Catherine the Great. They said, okay, this is great new farmland. The country wants us to move there, so let's go. And so thousands of Germans from Russia actually immigrated to the western states of our country. And this is a map showing where they settled. And I particularly want to point out to you that they settled in Kansas, and this is the Oklahoma. So there's settlements in Kansas and Oklahoma. You will also note that there were quite a few that settled in Washington. I might point out to you that if you know anything about Eastern Washington, there's a town over there called Odessa, Washington. And guess why it's called Odessa? Because it was settled by Black Sea Germans from Odessa. So they settled in the western states. They had their problems during World War I as well, because Germans were extremely unpopular and abused in many ways in our country during World War I. But they were very good farmers. They were corn farmers. They were wheat farmers. They were sugar beet farmers in Colorado and Montana. They were wheat farmers in Eastern Washington, and they settled in. And this is a family of Volga Germans in Oklahoma, and this is one set of siblings. And they all got together for a high school reunion. And this is a photograph of these are 14 siblings of Volga German ancestry from Oklahoma at their high school reunion. They were carrying on the tradition of having large families. I was contacted in the mid 1980s by the wife of one of these men. And she said, Dr. Bird, I've been scanning the internet and I found that you and your group at the UW are interested in the genetics of Alzheimer's disease, and I want you to study my family. My husband died with dementia. He's in this SIBSHIP. He had an autopsy done in Colorado, and it showed Alzheimer's disease. And I want you to know now that 11 of these siblings have developed dementia. And we said, wow, 11 of 14, that can't be a coincidence. And here's their family. And you can see this in the center is the 14 siblings. And sure enough, 11 of them developed a dementia. And we eventually had several autopsies on these people, and they all showed Alzheimer's disease. And of course, the other thing to notice is that as the story was put together, many people in this family had dementia, including the grandfather who was born and raised in Russia and was the one that had immigrated from the Volga River region to Oklahoma. And because this is an updated family pedigree, you'll see that in the next generation, there are multiple individuals with dementia. And this family said, oh, by the way, we also have friends who are living just north of us. This family lived in the panhandle of Oklahoma. They said, we have friends who have a family living in Kansas just north of us, and they also have Alzheimer's disease in their family, and they also are Volga Germans. And I went to visit these people, and talked to them about this. And not only were they Volga Germans, but the two families in Oklahoma and Kansas came from the same two villages right next to each other in the canton of Frank. And I asked our research nurse, Ellen Steinbart, to look into the ethnic background of some of the other families we had come across. And we found in our own files 3 more families that we had come across in the state of Washington who turned out to have a Volga German background. So suddenly we had 5 families, all with the same background. And because these families are very interested in their ancestry, they know a lot of things about their ancestors in Russia and even Germany, and they know the villages they came from. And we discovered that all 5 of the families we had come across came from the same 2 neighboring villages in the Volga River area. The son of one of the other people in this picture, Gary Reiswig, wrote this book about his family called The 1,000-Mile Stare. The family mostly didn't like to talk about the disease in their family, but they knew somebody was developing the condition when they became sort of apathetic and just sat around staring off in the distance. And the family called it the 1,000-Mile Stare. And this Gary Reiswig, when his father developed the 1,000-Mile Stare, he knew he was developing dementia. This is Gary Reiswig. And so, of course, our book has been written about the family, so it's not a secret that their last name is Reiswig. So we started looking specifically for German from Russia families with dementia. And to make a long story short, we eventually ended up with 21 families that were Volga Germans and 8 families that were Black Sea Germans. And some had early onset, some had kind of an intermediate onset, and some had late onset. And these were all families that had three or more affected people in 2 or more generations. And we eventually selected out 11 families that were all Volga German. They were all from these same 2 villages in the Volga German area, and they had quite early or at least intermediate age of onset. A number of autopsies got done. They all showed classic Alzheimer plaque and tangles. And here's the 2 villages. Here's the Volga River. Here's the west side where the Lutherans settled, and the 2 villages of Walter and Frank. Remember, one of the cantons was the canton of Frank. One of the villages in it was actually called Frank. And this is where the families came from. And the key concept here, and we wrote a paper about this. You can see this is from the Annals of Neurology in 1988. The key concept here is people were doing genetic linkage studies, trying to find genes for diseases. And because of it, the knowledge that there was familial kinds of Alzheimer's disease, people were sorting for large families to do genetic linkage studies to try and find a location in the human genome that contained the gene causing the disease. The trick was finding big families because you needed lots of people to do your genetic linkage studies. And what we said was these 11 families who all came from the same 2 villages and all had early onset disease, the likelihood is high that in fact they're all cousins. And if they're all cousins, they all have the same kind of genetic Alzheimer's disease. And this is what's known as the genetic founder effect. You have a large number of families that are all related to each other, and the same mutation is being inherited in the distant members of this one big family. And so we said, we don't have to deal with each of these families as a separate entity. We can combine them, and that multiplies the number of people we can use in our linkage study, practically 10 times. And so it was a huge advance in our ability to search for a gene for Alzheimer's disease. And we did that in the late 1980s. And the key lab here was Jerry Schellenberg's lab, which was at the VA hospital in Seattle. And the first gene for Alzheimer's disease that was discovered, as many of you know, was the APP gene, the amyloid precursor protein gene, mutations in which causing an amyloid vascular disease and then familial Alzheimer's disease were discovered in the early 1990s, 1990, 1991. And we looked for linkage of our Volga German families to chromosome 21, the amyloid locus, and they were not linked. And then linkage was found in some other families to a locus on chromosome 14 in 1992, which wasn't known at the time what the gene was, but it eventually proved to be presenilin 1, but the linkage was known. We looked for that linkage in our Volga German families, and it wasn't there. And then ApoE and the ApoE4 connection with Alzheimer's disease was reported in 1994, and our families were not linked to that region of chromosome 19. So they were not 21 families, they were not 14 families, they were not 19 families. And so we said there's got to be another gene for Alzheimer's disease that hasn't been discovered yet, which was news to everyone because in the 1980s, it was hoped that familial Alzheimer's disease would be a single disease and it'd be one gene and it would make the story simple. But of course, the story was not simple. And again, to make a long story short, Ellen Wiseman did genetic linkage studies on these Volga German families. And sure enough, she and Jerry Schellenberg's lab were able to show there was linkage to a site on chromosome 1 in these families. And that was submitted to Science in 1995. And while Science was reviewing it in 1995, the presenilin 1 gene was discovered on chromosome 14. And when that was discovered and the word got around, people said, oh, by the way, there's a homologue of presenilin 1 that's on chromosome 1. Isn't that interesting? And people did not know that we had this linkage assignment. But we heard the rumor that there was a homologue for presenilin 1 on chromosome 1. And so we said, well, wow, that becomes a candidate gene in our families. We got to look at that. And it's down in the distal part of chromosome 1. And sure enough, Efrat Levy-Lahad in Jerry Schellenberg's lab reviewed that gene in our family and found a single mutation in that gene. And so we contacted Science and said, oh, by the way, you're reviewing our linkage study. We have another finding that we'd like to submit to you, and that is the discovery of the gene in that linkage area. And the agreement was made with Science that they would form 2 back-to-back papers because they had just accepted the linkage paper. They said, okay, we'll accept the gene identification paper and we'll publish them back to back. And for those of you who are postdocs, I would like to point out to you that the first author here, Efrat Levy-Lahad, was a postdoc in Jerry Schellenberg's lab. And so she became the first author of 2 back-to-back papers in Science. How's that for a start to your career? Not bad. And so it now became clear that there were 4 genes that were very important players in the genetics of Alzheimer's disease. APP on 21, ApoE on 19, presenilin 1 on 14, and presenilin 2 on chromosome 1. And to this day, you know that these are still major players in the genetics of Alzheimer's story. And the presenilins are part of the gamma secretase complex, which of course has become the focus for not only research, but also for treatment trials in the disease. And Sumi Jayadev and I put together the presenilin 2 story, reviewed it, a paper in Brain in 2010 called Alzheimer's Disease Phenotypes and Genotypes Associated with Mutations in Presenilin 2. And here's the what's known as the Volga German mutation. This is the presenilin 2 protein, and you can see here's the Volga German mutation. And over the subsequent years, several additional mutations were found, although they're not very common. Mutations in presenilin 1 are much more common. And so what's the phenotype of these presenilin 2 families? We took our 11 families, and we compared them with 23 families that had mutations in presenilin 1, and also compared them with our whole UW ADRC collection of Alzheimer's disease families of late onset. And you can see that the presenilin 1 families have a mean age of onset of 45. The late onset people had a mean age of onset of 72. And the presenilin 2 people fall in between. They're sort of intermediate between those two. They have a mean age of onset of about 54, a little older than presenilin 1, younger than late onset, and clearly qualifying as early onset. But also notice two other things, and one is the age range. In our families, the age of onset ranged from 39 to 75. So a huge range in age of onset. And to this day, I think it's important to keep thinking about that because, there's some, what biologically is controlling that age of onset. They all have the same mutation in the same gene, but they have a 35-year difference in their age of onset. So why does somebody have an onset at age 40 and somebody else have an age of onset at 75 with the same gene? I think that still remains a very important issue. And also notice that the mean duration of the presenilin 1 families was about 8.5 years, but the presenilin 2 families live a bit longer. They had a mean duration of about 10.5 years, essentially the same as a late onset disease. And then in this paper that Sumi and I wrote, we actually had tables of all the families with their phenotype. And I won't go over all the details of all the families, but the thing to notice here is that we had collected information on 20. Let's see if we get one more. We had collected information on 101 affected people in these families. And there's the mean age of onset. There's their duration. And we had information on 35 autopsies in these families. And so a lot of neuropath information. And that they mostly begin with memory and cognitive problems, typical Alzheimer's disease, but sometimes start with personality and behavioral problems like hallucinations, delusions, even psychosis, which overlaps with some of the things you sometimes see in frontotemporal dementia, for example. And then here's the autopsy review of 18 of the cases. And you will see their Brock stage is 5 to 6, which is what you'd expect. Their plaque score is high. But two other things to notice is that alpha-synuclein pathology, that is Lewy bodies, are very common in the amygdala. And of course, that can happen in any Alzheimer case, but it's very common in the presenilin 2 cases. But TDP43 is not common. was almost never do you see TDP-43 in these cases, and I think that's also kind of interesting. And here's an example of a amyloid PET scan of someone with a presenilin 2 mutation, and you can see the hot red spots are typical Alzheimer's in the frontal and parietal area, but also notice that there's heavy amyloid deposition in the caudate and putamen, and that's unusual for late onset Alzheimer's disease, but it's quite common in both presenilin 1 and presenilin 2 families, and it's another way in which this disease is not quite like late onset. Not only is the age of onset different, but this striking accumulation in the striatum is also an important difference that distinguishes PSEN1 and 2 from late onset disease. So we're nearing the end of the story, but it doesn't quite end there, because here's a paper that was published in the German literature in 2008. And it was titled, "A 3-year follow-up of a patient with early onset Alzheimer's disease with the presenilin 2 N141I mutation." So this neurologist in Germany named Dr. Nickisch found a patient with early onset Alzheimer's disease that was familial, and what he found was the Volga German mutation. Here's the family. This is the case that he's reported. The person's father and grandmother were also demented. This was the Volga German mutation. And that person was from Fulda, born and raised in Fulda, and her family was from this area. So is this little map familiar? It certainly is. This is the exact region that many of the Volga German immigrants to Russia came from after the 7 Years' War. So this was really, we thought, likely a nice example of the fact that those people already were carrying the mutation for Alzheimer's disease when they immigrated, and they left behind family members who had the mutation. And one of the questions was, could we press that a little further genetically? And here is Dr. Alois Alzheimer. And I'm going to tell you that his case of Alzheimer's disease, the very first case that was reported by Alzheimer, was a person he had seen as a patient in Frankfurt. So Alzheimer's first case came from Frankfurt. And this is August D., Alzheimer's patient. So she was born and raised in Frankfurt, not far from Fulda. Alzheimer moved on to Munich, but he told his colleagues back in Frankfurt, if she ever dies, try and get a brain autopsy from her and send her the material. I'd like to see what it looks like. And so that became the first case of Alzheimer's disease. So we talked to Dr. Nickisch in Germany and said, if you could send us some blood from your patient, we'd like to compare it with our Volga German patients. And this was done in Chang and Yu's lab at the VA. And what he did was he took the DNA markers around the mutation on chromosome 1 and compared them with the DNA markers that occurred around the mutation in Dr. Nickisch's family in Germany to see if they were the same. And indeed, they were the same. And that means there was a greater than 99% probability that this modern German family actually were ancestors of the people that moved to the Volga region of Russia and that they all had the same mutation, and the hypothesis that they already carried the mutation with them to Russia, and that they had left back ancestors in Germany with the mutation was true. And there was a living person with the Volga German Alzheimer's disease in Germany. So that raised the other question of, could Alzheimer's first patient, August D., did she have the Volga German mutation? Why not? She was from the right region, she was the right age, and she had the right disease. And it turns out that when she died in Frankfurt and her brain was sent to Alzheimer in Munich, they also sent all her records. Alzheimer did the neuropathology in Munich. And following World War II, neurologists and archivists in Munich found all of this material. That's why we have a picture of August D., because her photograph was included in the record that Alzheimer had saved and that was found in the dusty archives after World War II in a hospital in Munich. And in addition to that, they found the slides from her neuropathology. And they had already taken a little bit of tissue from one of those slides and tested it to see what her ApoE genotype was. And I believe she was a 3-3. And so we said to these people, we said, wouldn't you like to take a little bit more of one of those slides and test it for the Volga German mutation? Because we think that she might indeed carry the mutation in presenilin 2. And they said, okay, we'll give it a try. We'll take a look. And they did. And here's the answer that was published in the Archives of Neurology in 2011. The answer was no, she did not have the Volga German mutation. So a great hypothesis, but it turned out not to be the case. Like so many other patients with Alzheimer's, the underlying cause of August D's early onset dementia remains an enigma. Another piece of this that was interesting is that the Volga Germans, when they started looking for new countries to immigrate to, and they all immigrate, and huge numbers of them immigrated to the western states of the United States, they went elsewhere as well, including particularly Central America and Paraguay and Argentina. And a family has been found in Argentina, a German from Russia family in Argentina with the Volga German mutation. And this was published in 2015. So that Volga German mutation has followed the Volga Germans to the United States, to Argentina, and still ancestors remain in Germany with the disease. So it turned out to be a fascinating historical and worldwide story. And on the sociology side, it took quite a bit of negotiations with this. I don't know if you can see the top of the slide. It's called the American Historical Society of Germans from Russia. We had never heard of it, but the Reiswig family belonged to this organization, and it's a United States organization of families who are of Black Sea and Volga German ancestry, and there are thousands of them. And so they have their own historical society, they have a monthly newsletter, they have an annual convention, and they have a headquarters in Lincoln, Nebraska. And in order to get this done, we actually had to have quite a few discussions with this organization, as you can imagine. They are very sensitive to being stigmatized because they're German. In Russia, they were stigmatized during World War I because they became the enemy. And in the United States, they were stigmatized during both World War I and World War II because they were either Russian or German, and neither background was popular in our country. And they had a lot of problems with ethnic abuse in our country. And so to find out that they had a hereditary form of dementia was not particularly attractive to them. And so we had many negotiations about how we were going to study the families, how we were going to report it, and what we were going to say. And the emphasis was this was important research about Alzheimer's disease, and they would be contributing to that research. They liked that idea. And we said this is not a gene that is common in your general population. This is relegated to a few small families from a few small villages, and is not something that your whole population should be embarrassed by in any way. And they bought that argument as well. And we made an attempt actually to document that. And Ellen Steinbart and I went to their annual meeting, which was just north of us in Vancouver, British Columbia, in 1996. We gave a talk about our findings, and we said we'd like to collect blood samples from anybody who has who is Volga German ancestry. And we said if you can document you have Volga German ancestry on both sides of your family, we would like to take a blood sample from you. And what we're going to do is see how common is this mutation in the general Volga German population. And we got something like 82 people who agreed to donate a blood sample. We took these back to Jerry Schellenberg's lab, and not a single one of them had the mutation, confirming the fact that this was not a common mutation in this population, but was something that was relegated to just a very few families. And so, in summary, the Volga German families have contributed substantially to our understanding of Alzheimer's. The early onset mutation is not common in the general German from Russia population. The mutation undoubtedly originated hundreds of years ago in Germany and has spread to at least 3 continents. And Alzheimer's original patient, although she was from the Volga German area in Germany, she did not have the Volga German mutation. And finally, and I like this point a lot, science always occurs in an historical and social context. And what I learned about European history and German history and American history in studying these families was all new, and I was fascinated to find out about it. And if you want to think about science occurring in historical context, just go watch the new movie Oppenheimer, and you'll see the historical context of science. And these are all the folks that helped in this research study over the years. Jerry Schellenberg's now at UPenn. Ellen Wiseman has just retired. Ellen Steinbart has retired. Mark Sumi has retired. Jim Leverance has moved on to the Cleveland Clinic. And Efrat Levy-Lahad, who had the 2 back-to-back papers in Science, has gone on to be a very well-known, very prominent genetic scientist in Israel, and has done landmark studies on the breast cancer genes in Israel. So that's my story, and thank you for your attention. I'm happy to take any questions.
Very good. Thank you, Tom. That was super duper interesting. So if folks want to ask questions, if you could raise your Zoom hand, that would probably be the easiest. How much, Tom, how much of this is you being a little bit of a history nerd, as well as like a scientist and a clinician for you sort of chasing down these details, versus how much of this is other folks doing some of the sleuthing work and understanding the interrelationship between the genetics and the historical movements of folks?
So I have to tell you, it's really a part of me being both a history nerd and having been trained in clinical medical genetics. Because in fact, this Reiswig family had been reported a few years before they contacted me in the neurology literature as a family with early onset familial Alzheimer's disease by the guys who did the autopsy on the woman's husband in Colorado. And they simply reported it as a familial Alzheimer's disease. And they also reported the other family, their friends in Kansas, as two families with familial Alzheimer's disease. They didn't even know that about their ethnic background. They paid no attention to that. And so what happened was this is one of these light bulbs going on during your research. I was sitting in the living room of this family when they were telling me their story and the story of their friends from Kansas. And they told me that they were both Volga Germans. And that rang my medical genetics founder effect bell. And everybody else studying these families, that hadn't occurred to them. But what I heard was, oh my goodness, these people could be distant cousins. And if they're distant cousins, they may have the same mutation. And if we find more families who are all cousins of these people, we can combine them into one big linkage study. And that tremendously increases the power of the linkage study. And that's exactly what happened. But it was my interest in history and my recognizing that the fact that they were from the same small area in Russia, that they probably represented the genetic founder effect, that's what made the difference in studying the family.
Interesting. Other questions from folks? Brian?
I can certainly ask if nobody else has got questions. How many families do you think are out there, or how many cases do you think are out there that have, this sort of early onset familial Alzheimer's disease, but they don't come from families that were so large and prolific, and so the power to find those mutations has really been limited? So you think there's, early onset Alzheimer's disease genes with the same sort of, potent effect size as PS1 and PS2 that we haven't found because they're only small families?
Yes, I think so. We know there are lots of early onset people out there, and they get screened for mutations. And if, for example, if your onset is before the age of 50, it's very likely that you have a genetic form of Alzheimer's. And when you screen groups of people with that very early onset, you find mutations in APP, PS1, and PS2. And I've actually had Chung-En Yu do that. But you also find people who have no mutation in any of those three genes. And some of them are familial. And so I have no doubt that they represent what you just talked about, Brian, and that is that they have a very rare mutation, either, out in the non-coding regions of these three genes or in some other completely different gene that we don't know about. And you've got to do very extensive whole genome studies on them to find that. But I think they're there. And an example of that, for example, is, Jessica Young and Sumi and I are reporting this family with a SORL1 mutation. And that's how that family was found. We did an exome scan of our early onset familial families that didn't have mutations in presenilin 1, 2, or APP. And we found this family with a mutation in SORL1. I think that should be in press now. And I think it's an example of a rare mutation in another gene that causes the disease. And I'm sure there are others out there.
Nice.
Corbin?
Really fascinating talk. It strikes me that in addition to the shared genetic history, these families have shared environmental history with the agricultural lifestyle. And I'm wondering has anyone, I just don't know, are there differences in age of onset or age of death in this population of people who live in urban environments versus rural, or any other environmental factors that may contribute to like that large spread?
Yeah, no, that's a great question. I think that large spread is important, and no formal epidemiologic study has been done on these families. By and large, as you say, there are, their general background is farm families, but in the last few generations, there are many that are urban, and I haven't noticed any particular association of urban versus rural and age of onset. So if it's there, it's not obvious, but no formal study has been done. And it's perfectly possible that there are environmental factors that are driving that, and we don't know what they are. But it's also, I think, equally possible that there are genetic factors. In fact, there are probably both. And it's not trivial, because if you could find something that delays onset of this disease, that's important.
Thank you.
Dee?
Thanks. Hi,
Sure.
Tom. I was thinking, sort of going forward with what Corbin said, and with relation to how you said there was such an age range in the age of onset with the one group with the like chromosome 1 mutation. I'm wondering how many family members or people with this mutation would you need to have information on to be able to start examining the genetic variability and what might contribute to changing that age of onset? Like, do you need hundreds, like thousands? Is it something that's even feasible?
Yeah, so I'm afraid that genetically you would need a lot, because it's going to be a fairly subtle change. And so I think you would need a lot of people. And it's one of the reasons we haven't done it, is because I think it would take an awful large number of people, and there aren't that many.
Okay, thank
Yeah,
you.
good question.
All right, Katie.
Thanks, Dr. Bird, so much. Sorry, we're two of us in the same room. I was struck by the little point you made about TDP43 pathology being very low in your N141I mutation folks. And I was wondering, is that true for, or is it known, is it true for all presenilin 2 mutations? Or is this specific to N141I, or is there something we can glean about the interaction of these pathologies that might be interesting biologically?
Great question. I like it a lot. But that's why I pointed out that factor, because obviously Caitlin Latimer and Nikki Lachko are really tuned in to the relationship between TDP43 and tau, for example, and that's not happening in this family. And I can't answer your question. All the other families with presenilin 2 mutations, and there aren't a lot, are almost all individual small families. And by and large, there's like only one autopsy in each family. And many of them were published before the TDP43 recognition of its importance in pathology. And so it's just not known. It would be interesting, for example, to compare it with presenilin 1. There should be lots of pathology around for presenilin 1, and what's TDP43 and presenilin 1. In fact, we have enough presenilin 1 brains to actually ask that question, and we simply haven't asked it. And if Caitlin Latimer was on this Zoom, we could twist her arm and say, look, you need to look at this. But but it hasn't been done. That's something that actually our group could do, at least in terms of presenilin 1, because yes, wouldn't it be interesting if there's a difference in the TDP43 pathology between these two different kinds of genetic Alzheimer's? And it could have something to do with the fact that if presenilin 1 has more TDP43, maybe that's why they have an earlier onset.
All right. Paul?
Thanks. Yeah, just go back to the previous point. I'm wondering, like what it would be really interesting to know how many individuals of this Volga German mutation you have in the pedigree, and what the earliest and latest, like you mentioned the earliest and latest age of onset. For the PISA mutation in PSEN1, it seemed like it was just one individual that had the APOE Christchurch variant that they were able to identify. So I wonder, with like extreme outliers, some of the earliest onset and some of the latest onset, whether you could even just do something simple like screening APOE to identify whether there's protective or risk variants that could influence age of onset.
Yeah, Paul. No, I think that the extreme people are interesting, and we did that for the Christchurch variant.
You did.
We did it for the Christchurch variant, and we had DNA from 3 of the oldest onset people in our Volga German families, and we looked for the Christchurch variant. Chung and Yu did it, and it was not there. And we actually published that a couple of years ago. So in terms of the late onset people, that's the Christchurch variant is not there. That's not influencing it. And there's another one that's been published that was in Nature just last year. The Reelin, right? There's a variant in Reelin that they're claiming has the same kind of effect, and I've proposed that's another variant we should look for in our very latest onset people that hasn't been done yet. In fact, I think that should be looked at in. We have this group of people that are called resistant and resilient.
Yeah, exactly.
Resilient, and we should look for the Reelin variant in those people. Is that playing a role or not?
Yeah, it's definitely a hot topic right now.
Right.
Dee, do you have another question? Okay. Juliana?
Yeah, I just have a really general question here because I'm curious. Are there other associated health conditions in the Volga German populations, or is it solely Alzheimer's that's really been studied? Does anything else crop up?
No, nothing else has cropped up. The one additional thing that we did notice was that the people who had the dementia, a fair number of them had seizures. There's a research interest in the whole Alzheimer field on whether people with Alzheimer's disease have seizures or epileptic seizures or not. And in this family, this group of families with PSEN2 mutations, they had more than the expected number of seizures. So for what that's worth, but no other medical condition has popped up. No.